Good afternoon. Today we are starting our new unit, Unit 8. This is going to be working with functions. Today we're going to be doing PO46. I can create a function table for a given equation. So we need to remind ourselves what a function is. A function, or a function table. A function table, remember, we've got our x and our y, and we can use that function table to graph from. So that x is the input. What you plug into an equation we could say what's being tested. So it's what you're putting into the equation. When we're doing a function table like I have up here, it's that independent variable, that x. That's what you're putting in. So when we were working on Khan Academy, they said the independent variable, you're just going to solve for that independent variable. That was the x. That's on the equation side. The output is the result of the equation. Or the test. So the result of the equation or test. So the y equals this equation. So you plug in the input, and what you get as your answer is your output. A function table is a way to organize multiple inputs and outputs. To get ordered pairs for a graph. So if we look at my function table on the board here, I've got my x, that's the independent variable. I would put that into the equation, and the answer I get is my y. I plug those into the function table, and now I have my x, y coordinates that I can graph. So we use that function table so we can get the x and the y, and we can graph it. The equation we get from a function table is also known as the rule of the table. When you were first learning function tables, you might have something like times 2. So you put in the x, and no matter what x you put in, you multiply it by 2. 2 times 2, 3 times 2, 4 times 2. So your y is the answer. 2 times 2 is 4. So you put the x in, the 2, you multiplied it by 2, and your output, what you get out of it, is the y, your 4. So we're going to create and let's just say that when we were first learning function tables, we were learning the more simplified. Now we're in pre-algebra, so our rules are getting a little bit more complicated. We saw that in Khan Academy. So if you're one of my friends who have already done all of their Khan Academy for this week, which remember they're due tomorrow night, you will see those function tables and they get a little more complicated. So we need to create a function table with at least 4 inputs or outputs for each given equation, for each given equation given. Oh my goodness, it's been a long day. Let me scroll up. Why do you think we want at least 4 inputs, outputs? Why should we get multiple inputs and outputs? Caitlin?
So it's easier to know the rule.
Say it louder.
So it's easier to figure out the rule.
So you can figure out the rule. What's another reason we might want multiple outputs? What's our end goal? To figure out the rule. But we also, if we want to graph a line, you can't graph just one dot. Okay, once you have at least 3, you can connect them to make a good line. 4 tells us, yep, this is what our equation should look like when it's graphed. Okay. Remember, oh, this is important. You get to choose your inputs for your table. So you're choosing your X. Okay? So you want to choose smart ones that are going to be easy to use. So when I was teaching function tables to the other math group, we had a function that might have been like 1/2 X. So put in X's that are going to be easy to have. Okay? So if you put in even numbers, it's easy to do the half. You don't have to worry about, okay, 7 would be 3.5. Don't do that. You would put in 2, 4, 6, 8. So your Y's are going to be a lot easier to get. Okay? It's not as easy to graph 3.5. It's easy to graph a 2. It's easy to graph a 4. Pick the numbers that when you look at what your equation is, will be easy numbers to work with. So when we say choose smart ones, choose the ones that are going to be easy to work with. So let's see what this looks like. If here's our equation, y equals x plus 3. What might a function table look like? Andrea? So the first thing we want to do is our table. We have the x and we have the y, our input and our output.
And then we could do x equals 1. So
we could do 1. So if we put a 1 in for x, what's my output going to be, Edward? 4. What could I do for another input? Is it?
2.
I like to keep it simple. 0, 1, 2, 3. 1, 2, 3, 4. Okay. If it is an easy equation that you're working with, do numbers one right after another. Then you can see that pattern easily and quickly. So if I put a 1 in, I get a 4. If I put a 2 in, 2 plus 3 is 5. 3 plus 3 is 6. 4 plus 3 is 7. I can see that pattern. I'm adding 1 more each time to my y's. If I add 1 more to my x, I'm adding 1 more to my y's. So now let's look at our next one. Again, your first thing is to make your table. We're going to label it. We have our x is our input, our y is our output. What do you think I should put for my x's, Joseph?
2.
Okay. So 2 times -2 gives me what, Maddie? -4. What can I put for my next, Andrea? 3. Remember, we're just keeping it simple. Just go in order. 2, 3, 4, 5. I put a 3 in. 3 times -2 gives me -6. 4 times -2 gives me -8. 5 times -2 gives me -10. It's easy to see the pattern. If I do just a bunch of random numbers, It's not so easy to see the pattern. It's not going to be easy to work with. Keep your numbers closer together so you can see the pattern that you're doing. These are kind of equations that we've already done, rules that we've done before in a function table. Now we're starting to get into more algebraic rules. This is more like getting into what we're working with in Khan Academy. So again, for my x's, 0, 1, 2, 3. Easy to work with. So if I plug the 0 in for my input, I'm putting 0 into the equation. What do I get for my y? Colin? -8. 0 times 5 is 0. -8 is -8. So now if I plug a 1 in, what am I going to get, Garrison?
If you were to plug a 1 in, wouldn't it be negative 3?
Yeah. 1 times 5 is 5. 5 minus 8, you get -3. Edward? What do you think the pattern is? It easy to know a pattern right away after just 2 numbers?
No.
You might guess what the pattern is, but you have to at least put in the third one to know for certain that it's your pattern. So what's your guess, Edward? Adding 5 each time? Let's check and see. If we put a 2 in for x, we get 10. What's 10 minus 8? 2. -3 plus 5 is a +2. Put a 3 in for 5, you get 15. 15 minus 8 is 7. So yes, our pattern is we're adding a 5 to our output each time. Oh, now we have our squares. I love my squares. So what should I put for my inputs, my x's? Molly? 0, 1, 2, 3. So if I put a 0 in for x, what do I get for my answer? Maddie? -10. 0 squared is 0. What if I put a 1 in, Jocelyn? -9. 1 squared is 1. 1 minus 10 is -9. Briggs, if I put the 2 in, so 2 squared is 4. 4 minus 10 is -6. See what I mean? It's not so easy to know what that pattern is when you do just 2. -10, -9, I might have mistakenly said, oh, then my next answer is going to be -8, then -7. You have to be careful. That's why we're saying you have to do at least 4 to see that pattern. If I put the 3 in, 3 squared minus 10, Cole, what do I get?
-1.
-1. What's my pattern that we're seeing there? Colin?
So first it goes down by 1, up by 1, and then up by 3, and then up by 5. So you're adding 2 to the.
Yeah, so we're adding those odd numbers, 1, 3, 5. So now we come to one of those functions that we want to be smart about, because we have that fraction there. So 0, 1, 2, 3 is not going to be the easiest to work with. What might be easier numbers for me to plug in for my input, Andrea?
4, 8, 12, 16.
So I'm still following a pattern with my x's, but instead of just increasing by 1 every time, why do you think Andrea chose these numbers, Paul?
Because 4 is a progressive.
And what do we know about these numbers? Yeah, the 4 is going to be the denominator, but these are all divisible by 4. 4 is a factor of each of these numbers. So if I'm doing 1/4 times 4, that's easy for me to do in my head. Okay, 1/4 times 4 is 1, plus 7 is 8. Now I'm going to do 1/4 times 8. Well, that's going to be 8 divided by 4. That's 2. It's easy for me to do in my head. So now 2 plus 7 is 9. 1/4 times 12 is going to be 3. 3 plus 7 is 10. And then 1/4 times 16 is 4. 4 plus 7 is 11. So when Andrea was looking at that, she saw the denominator was 4, so she chose numbers that had 4 as a factor. Easy to do that multiplication in your head. You don't have to worry about simplifying. You don't have to worry about improper numbers. She got whole numbers each time. So it was a smart choice for her inputs. You do not always have to go by ones. So think it through what you want to put for your inputs. Still follow the pattern, 4, 8, 12, 16. She's following that pattern. They're not random numbers. And we can see our pattern easily with the Y. But again, just like we saw in this one, don't think that you know that pattern immediately. Do your 4. Actually plug your X in 4 times to make sure that is the correct pattern. Paisley? Mm-hmm. So we did something wrong there. Because 5 times 5 is what? Yeah, so 5 times 5 is 25. 25 minus 8 is not 12. Okay, so we just went wrong with our math. How are we feeling about the function tables? Feeling good about that? All right, let's continue on. Oh, doesn't want to do the trick for me. All right. After a week of timing yourself during your morning run, you discovered that you can run 4 miles per hour. Let H represent the number of hours you run, and D represent the distance you run. What is the input? So which of these numbers is our input that we're putting into our equation? After a week of timing yourself during your morning run, you discover that you run 4 miles per hour. Let H represent the number of hours, and D is the distance you run. What do you think our input is going to be? Chase? It's going to be our hours. How many hours you run, and then we're going to find out how many miles you go, the distance you go. So what's the output? D, our distance. So now write an equation that relates the input to the output using the H and the D. What might our equation be? If we know how many hours we're running and we want to find out how far we can go, what would that equation look like? What do you think, Paul?
Well, since if you run 4 miles per hour, maybe you could do the distance, like how much hours you do in 4 hours maybe?
So how would that look algebraically?
In the function table, it looks like...
Not in a function table, I want the equation. So from the equation, we'll get our function table. Help them out, Joseph.
Would it be H times 4 equals D?
Do I do H times 4?
No.
that what we, say that again, Joseph?
H4 equals
Not H4. That doesn't look quite right.
4H.
4H. We put the number first and then the variable. So you had the right thought. Okay, so 4H equals what, Joseph? D. 4 times your hours equals your distance. All right, so we're going to create a function table that will show how far you run in 3 hours, 8 hours, and 12 hours, and 20 hours. How do I do that? Sam?
You plug in the numbers.
So the first thing I have to do is I have to draw my table.
Draw the table.
My input, instead of being X, is H. My output, instead of being Y, is the letter D. So then, Sam, what do I do?
Then you plug in the numbers. So 3, 8, 12, and 20.
So they're telling me what my input is. 3, 8, 12, and 20. Those are my inputs for the H. Now I need to find my distance. So I'm going to use that equation, and I'm going to put my inputs into the equation. So my input is H, so that's a 3. 3 times 4 gives me what, Maddie? 12. Now I'm going to put the 8 in. How far do I run in 8 hours, Cole? How far do I run in 12 hours? Well,
48.
and how far do I run in 20 hours? Thank you to my friends who are following along. 80. So that is our function table. How long will you need to run to go 62 miles? Oh. So how long will you need to run to go? So this is a 2-question problem. So we're going to do the first question first. How could I solve that? If my distance is the output, how do I solve this, Amelia?
You divide 62 by 4.
Yeah, because I know my equation is 4H equals D. I know my distance is 62 miles, and I want to find out how long. I want to find that hours. So 4H equals 62. I need to divide each side by 4. So H equals what? 15 and a half. So I'm going to need to run 15 and a half hours, because this is in hours. I'm going to run 15 and a half hours to go 62 miles. If I burn 250 calories per hour of running, how many calories will I burn if I run 62 miles? Leah, what do you think? 3,875. How did you find that, Leah? Shh, I need the whispers to be done. Say that again, Leah. So she knew she was going 15 and a half hours, and that she was 250 calories per hour. So she multiplied them together to get 3,875 calories. Whew. That's a lot of calories to be burning. Do you think you could do that in one day?
Yeah.
No.
You
wouldn't have enough.
15 and a half hours. One day is only 24 hours.
Yeah.
So that means you'd wake up, eat a quick breakfast, and then, no, it says run.
Red Bull.
Oh, no.
It's Red Bull.
Red Bull.
Water.
Yeah.
So,
So think about this. How far, oh, friends, how far is a marathon when somebody runs a full marathon? Briggs? 26 miles. 26 miles. We're running 62 miles. So that's like almost 3 marathons. So it's not so easy to do that in one day. You could run one marathon in a day, and then you need a break. Okay, let's look at, oh, friends, let's pull it back together. This objective, it's a power objective, so we need to make sure that we need to make sure that we are understanding it. There are 2 work pages that go with this objective. So we have our next page, and then that page after it, Mr. Schultz did this to that second page. When you get to you are building a floor for your deck. You did a big this on the teacher manual. Yay! So if that's on my teacher manual, that can be in your page. So you are building a floor for your deck problem, you can cross off. So it's not the whole page. It's just that bottom section. You are building a deck. So you still have a full page of work and the top half of that page. This is our assignment. So when you are finished with the assignment, when you are finished with the assignment, double check that you have Khan Academy done. Khan Academy is on function tables because I knew this was coming up this week. Getting us ready, thinking about those inputs and outputs. So I need us to be working on this now, coming in, asking if we have questions, not copying what our friends are doing because then we're not learning. Okay, friends can help explain it, I can help explain it, but we're not going to copy. Because when we copy, we don't learn it, we don't understand how to do the Khan Academy, we don't understand how to do the test. This is a power objective, so we need to make sure that we are focusing, especially when the teacher's talking. So to anybody watching this at home, we hope you are well and we hope to see you soon.